Unit 5 is about trigonometric identities. I'm going to start you off today with the basic identities. So first we need to talk about what an identity is, and then there will be some identities that you actually already know. We'll derive two new ones, I'll show you a common mistake, and then we'll run through some examples. An identity is a special equation with variables on both sides, and it is true for all inputs. So some identities that we could make up kind of here, 2x plus x equals 3x. It doesn't matter what I put in for x, both sides will always balance. Same for the following two. The last bullet point is probably the one that most resembles the identities we'll use in trig, because we use the 1 over x to replace x to the negative 1 when it's difficult to use x to the negative 1 in an equation. So we use identities to help simplify an equation to make it possible to solve. A lot of times this will happen through substitution. So the reciprocal and ratio identities are the ones that you already know. We've used these quite a lot so far. You should be aware that we will now be referring to these as reciprocal and ratio identities, with the top ones, these are our reciprocals, and the bottom two are the ratios. Now, you might not have realized that this is something that we can use, but it should make a lot of sense based on what we've already done in class. If we could use the points on our unit circle to give us the cosine and sine of x, then we should realize that the sides of the triangles could also be cosine and sine of x, or theta, which means we could plug them into the Pythagorean theorem and get sine squared plus cosine squared equals 1, because the hypotenuse is 1 on the unit circle. So, by extension, we have two new identities, where we take our initial Pythagorean identity, that's what these are called. If we divide everything by cosine, our first term becomes tangent squared, because sine over cosine is tangent, and we squared it. Then we get 1, and then 1 over cosine squared will give us secant squared. So here's our next Pythagorean identity. If we divide by sine squared, back at the original, we get our third Pythagorean identity. And there are a lot of other identities that come along with this. So these are the first three, but then rearranging them, you get the other 6. It's most important to know these first 3. It's very helpful to learn the other 6. Here's the common mistake, though. I mentioned that we squared something earlier. You can take a fractional identity, something that's a ratio or reciprocal, and you can square it and you still have an identity, because squaring a fraction is the same as squaring the numerator and the denominator, so it works out. You cannot unsquare the Pythagorean identities. So sine squared plus cosine squared equals 1. Sine x plus cosine x does not equal 1. No, no, no. When we simplify using identities, the two basic strategies are to rewrite everything using sine and cosine and then try to simplify into one term. For example, cotangent, I could write that as 1 over tangent, but I'd rather write this as the cosine of A over the sine of A, and then it's being multiplied by another sine of A. Those two cancel out. We're left with the single term cosine of A. Over here, make sure we maintain the fraction bar here. We have cosine A over sine of A and 1 over sine of A. So when we multiply by the reciprocal, we're going to have cosine A over sine A times sine A over 1. And you'll see we get the same answer. Here's an example that's a little bit more involved. So let's just run through and see if we can replace everything. Tangent becomes sine of, this is alpha over cosine alpha. Cotangent becomes cosine alpha over sine alpha. If you're smart, or I should say if you're quick on the uptake here, you might realize that since tangent and cotangent are reciprocals of each other, everything's going to cancel out and we get 1. Anytime you see 1 and something squared, either adding or subtracting, you should ask yourself, could this be a Pythagorean identity, or at least one that's been rearranged? And in fact, this is our first Pythagorean identity rearranged. And so the answer here, the most simplified version, is sine squared alpha. Alphas are really sloppy today.